Hello everyone, and my name is ID 400280, and today I'm going to talk about the anomaly detection using the generative adversarial networks, or we can call it for short as GAN. Okay, so let's start with introducing you all about the definition of anomaly detection. Anomaly detection refers to the task of identifying abnormal data which are significantly different from the majority instances. But the instances that I've just mentioned is not only about the image, it can be referred to a signal as well, as you can see on the picture on the right. But in this presentation, most of my examples will be given as the image, as it might help you to understand the concept more easily. The task of anomaly detection can be subdivided into two categories. The first one is outlier detection. The data may contain outliers which you want to identify. The second one is called novelty detection. In novelty detection, you can have a data set that contains only good data, and you're trying to determine whether the new observations fit within the existing data set. At this point, some of you might be thinking that this kind of task could be done easily even with a simple machine learning method, such as using a convolutional neural network or CNN model. It is true that we can use the CNN model to do this task. So to do this task with CNN model, we need to divide the architecture of the model into two stages. The first stage is the segmentation stage, which will be responsible for segmenting or locating the anomalous points or areas. So when you train the model at this first stage, only the network that are responsible for segmentation will be trained, and the network that are responsible for classification will be frozen, as well as when you train the second stage, which is a classification stage. When you train the network in this stage, the network in the first stage will be frozen as well. But this stage is heavily rely on the segmentation network, because if you cannot locate or segment the anomalous area correctly or clearly, then the performance of the classification process will be dropped. But using CNN model has one big disadvantage. That is, in order for them to perform well, we need a balanced data set. So in this sense, when we are talking about anomaly detection task, we need to have normal data and abnormal data equally. But in practical, if we need to create our own dataset, we will find out that it is much easier for us to find the normal samples than to find the abnormal ones. So we will face the problem called class imbalance problem, which will decrease the performance of the CNN model. So to solve this problem, generative adversarial networks have become one of the best approaches. But how can GAN solve this problem? Let's see what it is and how it works. A generative adversarial network is a machine learning model in which two neural networks, which are the generator and the discriminator, compete with each other by using the deep learning methods to become more accurate in their predictions. To understand the system more easily, I'll explain with this picture. This system will consist of two main components, which are the generator and that responsible for generating a fake samples. So we're gonna compare it as a forger, and the discriminator, which responsible for detecting the fake samples, we're gonna compare it as a policeman. In these situations, suppose that I want a fake Japanese banknote. So I hire this forger to make a Japanese banknote, for example. But this guy have never seen Japanese banknote before. So he'll try to guess what it will look like. After that, this guy walked to the police station pretending as a good guy and says, "Hey, Mr. Policeman, I found a Japanese banknote dropped on the floor." Now a policeman who have real samples with him gonna say, "No, this is not a Japanese banknote. A Japanese banknote should have an empty circle at the center." Now the forger remember them and keep improving, keep pretending to be a good guy, walk to the police station until the policeman cannot distinguish between the fake one and the real one. And that is when my objective is completed. So how can GAN solve the salience problem? From my previous explanation, you can see that GAN need only one class for training. Basically, the system just asks you what you want to generate. If you want to generate a Japanese banknote, then just give me a Japanese banknote sample, and that's it. So not faced with the class imbalance problem anymore. Okay, so how do we use this system to do the anomaly task? As I mentioned earlier, that it is easier to find normal samples than to find the abnormal ones. In this case, suppose that I trained again with chest X-ray images of normal people or healthy people, and as a result, the system will be able to generate a healthy people's chest X-ray images. Now I got a new patient and want to know if there are any anomaly area in the lungs, which can lead to an illness. Of course, if my patient is healthy, then there should not have a difference between the input, which is a real chest X-ray image, and the chest X-ray image reconstructed by the system. If we subtract both images together, you can barely see things in the third picture because there's no significant difference between them. But for this case, the abnormal lungs, you can see that the reconstruction image from the system doesn't contain the tumor areas. That's because we only train the model with only normal samples, which means our system doesn't know how to generate a tumor. So it generates a healthy version of patient's lung instead. And after subtract both images together, now the anomalous part is highlighted and localized. That's when our job is done. So in conclusion, we can summarize that GAN shows superior ability in generating real images. By training with a dataset that contains only normal samples and learning their feature representations, so the abnormal samples, which are poorly constructed, can be detected. Thank you for your attention.